Welcome, everyone, to this next session of Geometry, Cosmology, Spirituality. It's a much more reasonable time of the day, at least where I'm coming from, 11:30 in the morning. Last time, if you were with me, it was midnight and beyond. Now, for this new moon, I'm going to go back to what I was talking about at the last new moon. So that's in the fifth session. Now, if you want to look up the sessions I've done up to now, this is the seventh one. You can look up my YouTube channel. If you just you can just Google Tom Bree YouTube channel and it should come up. Now, this seventh one, as I say, it's following on from what I did in the fifth one, and it was looking at the golden ratio and how it begins to become present in the relationship between Mercury and Venus. Now, I'll show you a little bit more. I'll show you how it happens with Venus, but also how you have similar numbers or similar Fibonacci numbers with the relationship of Mercury to Venus, but also with Mercury to Earth and Venus to Earth. So everything begins at the center, the Sun and Mercury, as I showed in the earlier sessions. It begins with pi, with 22/7 pi, but then it starts to emerge into this generative ratio, that is the golden ratio. This is a ratio you find throughout the natural world. Things that grow often have golden ratio or Fibonacci numbers within them. So there's this movement, I suppose you could say, from, I suppose, the unity of the circle and then out to this generative ratio, the golden ratio. So a bit more about that for today. I'm going to do a small recap with some of what I showed a month ago. Now, if you want to see this in more detail, look at session number 5. So from the new moon session a month ago. But I went through this at that session, and I'll go through it again just to lead on to some of the other stuff that I want to show. Now, what we have here, this 11-pointed star with an outer circle that is obviously the container of the star. We're going to look upon that as being the orbital circle of Venus. And then there's two circles. There's a smaller circle here you can just about see, which is there at the center, and then another one here. Now, these two inner circles that I've just shown, they plot the range within which Mercury orbits the Sun. If we're saying that this is Venus's circle, then this would be Mercury's range of orbit, because Mercury has a very, what's known as eccentric orbit. It's quite an egg-shaped orbit, rather than a very circular one. Venus's is almost perfectly circular. It's only a very small discrepancy in that circle. Now, what I'm going to show is the movement of Mercury and Venus in relation to one another according to this 11-fold division of the cycle, because it's useful for showing the orbital relationship. Now, here they start moving. Now, as you can see, Mercury moves a lot faster. Mercury's orbital period is 88 of our Earth days. So that fits very nicely with this 11-pointed star. Now, Mercury has done one complete orbit at this point, whereas Venus is just over 1/3 of the way around her orbit. So we'll carry on from here. Now, you'll see they're gradually about to meet for the next inferior conjunction, which is what they began from. And it's at this point here, when you get past 7 of those 11 star points. Now, I've talked about the relationship of 7 and 11 a lot in the previous sessions, and the way in which it relates to 22/7 pi, because of course 11 to 7 is half of pi. Now, the actual correct conjunction point is a little bit beyond this star point. It's at this place here. It's about 144 and a bit days. So that's where they actually conjunct. So in one sense, you could say, well, does this star actually apply to what I'm showing you here? Well, I'm going to show you, as I showed before, this really interesting numerical aspect to this, whereby the discrepancy actually does something very interesting in and of itself, because the discrepancy or the difference between the point at which they get to this line that they're on, this line within the seventh point within that 11-pointed star. It's divided by 1 Earth day. So I'll go through that. So Mercury moves around 11 of these stellations plus 7. So that's how it's gone around to get to where it is here. Whereas Venus has just gone around 7 of the star points. So from the starting point around to here. Now, to get to that line in the star where Mercury, the red point, now is, takes 144 of our Earth days. Now, for Venus to get to that line, takes 143 of our Earth days. Now, obviously, an Earth day is the amount of time it takes for Earth to spin upon its axis. So it's very interesting that this period of time happens to come in at this point. If we look upon the planets as an emanation from the sun in symbolic terms, then we have this movement from pi and then moving slowly into the golden ratio, as I'm about to show you. And then it's from that that the day or the period of 1 Earth day is generated. So as I say, if they were to move a little bit further, they'd reach their true conjunction point, which is 144 and a bit days. Now I'll recap over these two sequences again. Lucas and Fibonacci numbers, they're the same sort of thing. You do the same thing to generate these number sequences, but they begin from different numbers. So that's why they give different number sequences. Fibonacci numbers, the lower ones, they begin from 1, and you add the number you have to the next one, and that gives you the next number. And so 2, we'll go back to the one before, plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, and so on. Now, if you begin from the number 2, you get a different sequence, and they're known as Lucas numbers. And it's the Lucas numbers, which, as I explained before, they have these 4 numbers here, which are all, I suppose you could say, pi-friendly numbers in relation to the division of the circle into 22 and the diameter of 7. So 11 is half of 22, 11 plus 7 is 18, and 29 is 22 plus 7. So there's all these relationships whereby even though this is actually a golden ratio sequence, effectively, you have these pi numbers within it, which can move you through from pi to the golden ratio. Now, like I say, there's more detail of what I'm describing here in the session, the number 5 session. So there's a bit more about the golden ratio nature of these sequences. Now, I'm going to focus on these 2 numbers, the 6th and the 7th number from both of these sequences. And I'm going to color those 2 red and the other 2 green. So the red ones being the mercurial color and the green ones being the Venusian color. Now, if we multiply the numbers together, if we multiply 8 by 18, we get 144. So there's that number, the amount of time it takes for Mercury to get to that particular 7th stellation within the star. Whereas if we do 11 times 13, we get the Venusian number, the amount of days it takes to get to that point in the star. So it's a really interesting numerical correlation. Now, also, it brings us from the pi numbers of the Lucas sequence into the Fibonacci numbers, where you find 8 and 13. And this is where you really start to enter into what's known as the Venus pentagram. Now, the Venus pentagram is the description that's given to the numerical relationship that exists between the orbits of Earth and Venus. So their movement in relation to one another naturally brings up these Fibonacci numbers, which are very close approximations to the golden ratio. Now, the fact that you have that means that you're going to have 5-fold symmetry. So that's why the Venus pentagram is so called. And what you're looking at here from John Martineau's little book of coincidences is Earth is at the center, and then that curved line that creates the 5-fold pattern is the path of Venus around what we can look upon as a fixed Earth. Now, this is inevitable because of the golden ratio relationship, the Fibonacci relationship that's there. You inevitably have 5-fold symmetry because that's what is generated by the golden ratio. Now, let's go back to these numbers that we were just looking at. Now, I'm going to change them a little so that we can look at these Venusian Fibonacci numbers. So you can see those three that I've colored green, 5, 8, 13. They're the three numbers that are significant in relation to this orbital relationship of Earth and Venus. And I'll describe how. Now, Venus, in relation to Earth, Venus plots out a five-pointed star, so a pentagram star, but it also plots out an eight-pointed octagram star. Now, the amount of time it takes for this to happen is 8 Earth years. Now, 8 Earth years are virtually identical to 13 Venus years. So this is how you have this 5, 8, 13 relationship that becomes apparent once you bring, or once you look at this relationship of Earth and Venus. Now, just to describe simply what happens, the Venus pentagram, if we have a conjunction at the top, so the sun is in the middle, Earth is on the outer circle, Venus is on that inner circle. They move around, Venus moves more quickly than Earth, and so they reach another one of these inferior conjunctions where they form a straight line with the sun at this point here. And I've drawn a line to show where Venus was and where Venus has now moved to. Now, the next time they conjunct is over here, and the next time over here. And so this is the Venus pentagram. Actually, the conjunctions happen in the order of the generation of the pentagram star as well. Now, at the same time as that's going on, there's also an octagram developing as well. Now, I've got them slightly to the side here, just for the sake of the orientation of the star that's going to be generated. If we look at the position of Venus on the same day every year, that's how we get these 8 points of the octagram star. So Earth has gone around its orbit once, and this is where Venus now is. So we draw a line to where Venus now is. Now, 1 year later, now this is where Venus is, and this keeps going. So each year, there's this new position that Venus is in. And after 8 Earth years, we end up with the Venus octagram. Now, these two numbers, 5 and 8, they're, of course, those Fibonacci numbers that we were just looking at. Now, this appears to be ancient knowledge because the way in which Ishtar, who is the Babylonian Venus, the way in which she was depicted in ancient steles such as this one is as an 8-pointed star. So we can assume from that that the Babylonians knew this. The Babylonians knew a lot more complex stuff than this. This is a relatively straightforward thing to be able to see. Now, interestingly, the 5 and the 8, which develops between Earth and Venus, happens through movement. So you could say it's through generative movement that it generates gradually over time. But all of the time that that's happening, there is actually this spatial relationship between Mercury and Earth, which has those same shapes, the pentagram and the octagram. Now, what you're looking at here, the way to look at this diagram is that you've got the outer circle. First, I'll describe the pentagram and the octagram and their relationship. If you put the pentagram and the octagram in the same container circle, so you can see they're in the same size of circle. If you then look at the two smaller circles, there's a smaller circle which is containing that pentagon, like so, and then there's this one here, which is contained within the octagon. Now, these two circles are virtually the same size. They're really, really similar. And this is actually used in the design of the cathedral at Wells for the Lady Chapel. I'll show that on a future one. But in this particular instance, what we're going to look at is how this is also, if you were to look at Mercury and Earth in terms of their sizes, then this is their size difference. So if this is Mercury, this is Earth. But rather amazingly, if you were to look down on the orbital circles of Mercury and Earth and you regularized them so that they were their mean circle, then this would also be the orbital circle of Mercury, and this would be the orbital circle of Earth with the sun in the middle. So you have this relationship between Mercury and Earth, both in terms of their size and also their orbital proximity. Now, this is all going on at the same time as Earth and Venus are creating these stars through a generative movement. So it's a fascinating correlation between these three planets. Right, back to this doorway. This is a doorway that I showed a month ago as well. This is the doorway to the sacristy in Wales Cathedral. So it's a very significant doorway. The sacristy that it leads into has got a lot of interesting carvings within it. And this doorway, as you can see, it's off center within its bay. So between these two pillars, it's off center. And that's because it's at the golden section of the bay. So this relationship of lesser and greater that you have with the golden ratio is expressed through the position of this doorway, in the sense of there being a greater part here and a lesser part here. Now, the back door of the sacristy is also at the golden ratio of its own particular wall as well. And so we have this, I suppose, this apparent symbolism of passage through the sacristy, because it leads to then a very important octagonal room, which is known as the undercroft. And so I suppose you have this idea of passing through various stages, as it were, or passing through particular doorways from one place to another. And so in a certain sense, you could say it resembles an idea of ascending through various different stages. And that's really what I'm going to suggest with the next thing I'm going to talk about, which is Plato's divided line. Now, the analogy of the divided line is something that is mentioned by Socrates in Plato's written work, The Republic. This is where it's mentioned. You surely apprehend the two types, the visible and the intelligible. I do. Represent them then, as it were, by a line divided into two unequal sections. Now, of course, there's many different ways of dividing a line into two unequal sections, but there is a certain suggestion that what he's alluding to here, to a certain degree, is the golden ratio. Now, interestingly, there's work being done on this where it's been pointed out that these sentences that you're reading actually happen at the golden section of the Republic. So if you wrote the Republic as one long line, the point at which these words are said is, you could say, at this point here. So if this is the beginning of Republic and this is the end of Republic, this is where the mention comes in. Now, the person who did this work, he wasn't so sort of geometry and mathematically orientated. And so there's something he missed out, which I want to sort of highlight now. And that is that the actual point where this is said is actually much closer to 5/8 of the actual dialogue. Now, of course, if you're counting in whole numbers, as you would do if you're counting sentences or syllables or whatever it is you're counting, if you're measuring a dialogue of words, then you're counting in whole numbers. You can't have 1.618033989 lines written down. You have to have rational, I suppose, units expressed through numbers of lines or whatever it is that's being used for the measurement. So it's actually if you divide the Republic into 8 parts, it's at that the end of that 5th part where you have the 5/8 division. That's where this mention is made. So again, you have this rationalization of what is essentially an irrational. Now, what Plato goes on to write in this dialogue is he says to cut each section again in the same ratio. So each one of those parts, like this longer part and this shorter part, they also get divided by that same ratio that's been used to do the first division. Now, a really interesting part of this mathematics, which I'll come back to in a little bit, is that whichever unequal division of the line you use, whether it's the golden ratio or any other division, you're always going to end up with these two middle parts the same length as one another. Now, there's something significant in that, which I'll talk about in a second. Now, back to the general thing that's talked about with this line. What Socrates is doing when he's mentioning this is he's using this as a visible analogy for the philosophy that is associated with Plato and Socrates. This idea that there are these two aspects, these two things that we experience as humans. There's the visible world that we experience through the senses, and then there's the intelligible world, which it relates more really to the unchanging and what we can know through the intellect. Now, the subdivision that you get in each one of those is described at this point in the dialogue. So the visible world consists of these two things in terms of how it's talked about here. There's the shadows and the reflections of visible objects. So that's not objects themselves. It's sort of, I suppose, are indications that the objects are there. And then the next one is the actual objects. So you have an indication of something in that first uh, part here, but then you have the thing itself in this second part here. Now that's understood in terms of how we experience things with our senses. Now what then happens is he goes over to look at the intelligible side, and he associates this first part, the larger part of this part of the line, with mathematics and geometric theorizing. He sort of associates it with the previous one. He says that this is thinking and theorizing about objects that are in this area here. But it's about thought process, this particular part. Whereas the fourth one, which is described as noesis, could be described as the direct apprehension of knowledge itself. So it's not so much about thought process, it's about the immediate knowing rather than going through theorizing. Right, looking at this, you can see how the relationship of this to this is the same as the relationship of this to this. And so we can say that if this is the indication of this itself, then this is an indication of this. Now, the thing about geometry and mathematics is, of course, that it's dealing with that which is eternal and unchanging in its truthfulness. So you could say in that sense that this gives an indication of the direct knowledge of noesis, of that which is eternal and unchanging. Now, finally, what I said about these two being the same. Now, this is very important from a perspective of a geometer, because these really are the two realms within which geometry and number take place. This is the visible objects. Obviously, when we're drawing geometry, we're drawing these eternal forms of number, which can be contemplated in the intelligible mind. We can sort of have mathematical reasoning, but that mathematical reasoning becomes visible in this area. So perhaps this is an indication of why these two parts within this analogy are always the same size, because it's part of, I suppose you could say, one and the same experience of geometry and number. Now, of course, the other thing about this is that this can be looked upon as an ascent from that which is least reliable, you could say, that which can give us least knowledge, to the direct most knowledge and direct knowing, you could say. So there is an ascent that we can associate with this ascent through 4 levels. So with that in mind, I just want to point out again these 2 golden ratio doorways at Wells Cathedral that leads, one at the beginning of the sacristy and one at the far end of the sacristy, that then leads into an octagonal room that seems to have an association with a heavenly place. More about that in another session. Right, what I'm going to do is get us to draw the divided line by putting squares next to each other, which have golden ratio relationship. So I shall de-share my screen and okay, welcome everyone. Thanks for coming. I shall switch on my camera. Right, all we need today is a piece of A4. That's fine. We're going to work, what we're doing is quite small. I'm just going to get a bit more light. Right, with my paper in landscape orientation, I'm going to first measure 3 inches up on this side of the paper and on the other side, so I can get a horizontal line, which so I'm making a mark here, 3 inches, 1, 2, 3, up the page. I'm going to do the equivalent thing the sides as well. And I'm going to put a faint line along here. We don't, in the end, we won't want all of this line. Well, having done that, I'm now going to measure 5 inches along the line and make a dot. So 1, 2, 3, 4, 5, and then a dot goes in there. Right, having put that dot in, I'm now going to get 2 inches on my compasses. And draw a semicircle. Right, then in goes compasses to here. And I'm drawing a quarter circle, like so. In fact, giving myself an image of a bird opening its wings by the rising sun. It's quite a nice image of that. I always think of that when I see this. Beginning its ascent. Now we'll want these wings to come just above these 2 points here. So if they're a little bit short of that, make sure that they go all the way so that if you put a vertical line up, you'd be able to hit those 2 lines there. Right, I'm now going to use these 2 points here to get a bisector cross, like so, directly above. Right, as you can see, I'm using that cross there. I'm going to put in a vertical line, though it's only going to be within the semicircle, like this. Now in goes the compasses at the top of that semicircle, and now do this. Right, as you can see, I'm going into the tip of this petal up here, and I'm going to just do a quarter circle, like with this. So just in case you were doing something else when I did that, those final arcs that I put in came from the tips of those petals there. Right, as you can probably see, we've given ourselves two squares. So these are actually going to be I'm doing this in much heavier line. Now I'm going to actually fill in the bottom line in a while because I'm going to put another square here and another square here. So I'll do the whole of the divided line um, with heavy pencil at the end. Right, the next thing that we need to do is I'm lining up these two intersection points, but I'm just going to draw a little line like this, just that. And then I'm going to do this with my compasses. This requires opening the compasses up a little bit. I'm going to bring it down and make a mark like so. I'm doing it just a little bit below the line. Right, now I'm going to reduce the size of my compasses so that I have the distance, that distance. Now this is smaller by the golden ratio. If this is 1, this is 0.618. Or if this is 1.618, this is 1. And I'm now going to make a square here as well. So first of all, from that point, I can put that arc in. And then from that position, this arc goes in. Then I can go to here. We're making the same shape as these crossed petals. I'm doing the same thing here. There's just a particular roundabout way that you have to do it. So first of all, I drew from that point and did that. Then I drew from that point and did that. And then from that point to do that. And finally, having obtained this tip of the petal, then I was able to put in the final one there. I'm going to turn that into a square as well. Right, finally, I'm going to take this measurement. You can probably see there's something quite similar to Fibonacci going on here in the sense that I'm taking that one and that one to get the next one. So the previous number plus the present number gives you the following number. And what we've got here is going to be the next square along. I'll just make sure I've got that on. Now this one I've done, and I've used my eye just to see that it's going to coincide with an extending of this line here. So that's what I'm going to do in a second. And this one just needs to go to above where the point of my compasses is in the page. So we're just going through the same process again, doing another square. Right, now the way I'm going to get this top corner this time round is like with this. So as you can see, I'm just extending that line up until it meets the arc. And then I can do this. Point of the compasses in the top of that line. And then finally, tip of that petal, I can just finish off like so, just for the sake of neatness. I don't have to do this particular line, but it looks nice to have the same pattern in all of them. Right, now I'm going to put in the whole of that line. This is going to be our line divided into unequal parts. In fact, I'm going to put some lines here as well. So where every edge of the square is, and then I'm going to turn it round and look upon this as being the divided line as I showed you in the slide. So I'll write the descriptions in each one. So shadows and reflections of objects. objects themselves. I'll call that one geometric theorizing. He talks about maths and geometry with that particular one. And finally, noesis. The noesis is the activity of the nous, the intelligence. Now you should find, well, bearing in mind that this is 2 inches, so you could say it's 1, 2, 3, 4, 5, 6, 7, 8 quarter inches. So you can look upon that as being 8, and look upon that as being 8, as in 8 units. This then is just very slightly off 5 quarter inches, because obviously 8 to 5 is a Fibonacci relationship. It's not a true golden ratio relationship. And likewise, this would be just off being 13 quarter inches, because again, it's 8 to 13 is an approximation. And this is pure golden ratio geometry that we're doing, which naturally arises out of these sort of circular relationships that we've been doing with these arcs here, which bring forth the square. Okay, everyone, I'm going to leave it at that. Let me just get my camera on to say hello and goodbye again. Thank you for coming to this session. I'm going to carry on with golden ratio stuff next time, I think. In fact, before I go, I'll just show a few more slides as well, just to mention some of what I'm doing at the moment. Now, this is a course that I'm going to be running in Wales on the 24th of March to the 31st of March. So there's still a few places left on that. We'll actually walk the Venus pentagram in this particular course, as well as creating a labyrinth and walking a labyrinth. I'm hoping that might be in or around the cathedral, in fact, the labyrinth. That's not confirmed yet, though. And then there'll be lots of drawings, discussion, and cathedral visits relating to my book, The Cosmos in Stone. So you're welcome to come on that course. Just get in touch with me if you'd like to book on. Now, another thing I'm going to be teaching at in a few weeks' time is for the Fintry Trust. And this is a Candlemas retreat just on the weekend of the 2nd to the 4th of February. So do get in touch with the Fintry Trust if you're interested in going to that one too. Now, the next session, which of course will be a full moon, is happening, again, it's at a reasonable time. It's not midnight. It's 5:30 in the afternoon on Thursday, January the 25th. So do join me then. And I shall look forward to seeing all of you then. Have a good day.
Thank you, Tom.
Okay, thank you.
Thank you, Tom.
Bye.
Thanks, Tom.